Welcome to today's webinar, Capturing Respiration Data to Detect Patient Deterioration Sooner, discussing methods and technology. As we go through the presentation, please use the chat box to submit any questions you may have. We will answer those questions during our Q&A session following the presentation. You will also notice a box on your screen with polling questions. We encourage you to participate in the polls at any point during the presentation. Today's webinar will be presented by Tiffany Moon, Global Product Manager of Patient Monitoring, and by Kevin Payne, U.S. Manager of Patient Monitoring Marketing at Hillrom. Tiffany will now begin the presentation.
Thank you, Natalie. Our goal for today's webinar is to introduce some key concepts around capturing respiration rates, particularly in general care areas. We hope that by the end of today's presentation, you will recognize the importance of objectively capturing respiration rate as it is the leading indicator of patient deterioration. First off, let's look at why respiration rate is so important. For one, its normal values are breached before those of other vital signs in nearly all states of clinical decline. Respiration rate often offers the earliest warning signs of conditions like sepsis, but unfortunately, it's the least often recorded vital sign. When captured, it can help you detect and respond to patient deterioration sooner. In general care areas where patient acuity levels are rising, but staff-to-patient ratios remain the same, undetected or delayed detection of patient deterioration can lead to serious consequences. These included increased ICU transfers, increased code blue rates, increased cost of care, longer hospital stays, and even higher patient mortality rates. Let's look at some statistics. Respiratory compromise can increase hospital stays by as much as 180%, cost of care by 47%, and lead to a 29 times higher patient mortality rate. Numerous studies indicate that this is not just a problem in the United States, but one also experienced around the world. During one study conducted in Japan, 15,724 adult medical patients were discharged from the emergency department. Of these, 170 patients revisited the emergency department because of clinical deterioration within 2 days. Among their initial vital signs, respiratory rate was less frequently recorded than other vitals. Overall, patients in the deterioration group had significantly higher respiration rates than those in the control group. Analysis revealed that respiration rate was an independent risk factor for clinical deterioration. A study conducted in Denmark also indicated that respiration rate is often not recorded. It stated, "Some argue that a reason for not measuring respiration rate is a lack of knowledge of its importance as a useful marker in assessing patients at risk of serious adverse events. Others suggest that it is not measured because there is no automated respiratory measuring device outside of the intensive care unit, and instead the pulse oximeter is used in assessing the respiratory state of patients. It therefore becomes challenging and time-consuming to measure respiration rate, making it more laborious and tempting to omit." The way we can get ahead of patient deterioration is to identify the signs earlier. And one of the best ways to do this is by capturing accurate respiration rate data. Now I'm going to hand this off to Kevin to talk about some of the different methods and technologies that are available to help you capture respiration rate.
Thanks, Tiffany. Respiration rate is often captured manually by visually assessing the patient. However, this more subjective method often leads to inaccurate measurements because calculations and acquisition methods can vary widely based on clinical experience and protocols. Today, we're going to focus on more objective ways to capture respiration rate data digitally, and we'll talk about RRP and end-tidal CO2 technology. Current research shows that respiration rate is the most frequently missed vital sign during patient rounds. However, changes in respiration rate are more likely to help you discriminate between stable patients and patients at risk. Therefore, it's critical to obtain accurate respiration measurements instead of relying on visual assessment, which can be subjective. In one study, nearly 72% of respiration rates were recorded as either 18 or 20 breaths per minute using visual assessment. However, trained observers found the same values only 13% of the time, showing significant accuracy issues with this method. Now let's talk about some options for digital respiration rate capture. For patients who you're spot checking today, RRP technology offers speed and accuracy while fitting into your standard clinical workflow. You can leverage the simple, automated measurement of episodic respiration rate in less than a minute. Masimo's new RRP feature uses proprietary signal processing technology to analyze changes to the plethysmographic or pleth waveform over the respiratory cycle. This is how it calculates an accurate, objective respiration rate. But what about your patients who are at a higher risk? Risk factors and comorbidities are increasing, and patient acuity levels are rising in general care areas. In the U.S. alone, there are 6.2 million high-risk patients in med-surg units. Is spot check monitoring during routine vitals enough for these patients? That depends. In many cases, end-tidal CO2 can help capture the critical information you need to keep higher-risk patients safe. Let's explore who falls into a high-risk category and may be an ideal patient for capnography monitoring. Patients with risk factors such as pre-existing pulmonary or cardiac conditions, post-surgical patients who may be on opioids for pain management, or those who are elderly or obese may be considered higher risk. But which of these patients requires continuous end-tidal CO2 monitoring? Medtronic's Prodigy study helps answer that question. This global 16-site study, the largest of its kind, has developed an easy-to-use risk stratification tool. The tool provides a Prodigy risk score, which serves as a guide to identifying patients who would benefit most from continuous capnography and oximetry monitoring on the general care floor. High risk factors indicated by the study include age, sex, previous opioid use, sleep-disordered breathing, and known chronic heart failure. For example, 46% of patients receiving opioids on the general care floor experience respiratory depression, so it is extremely important to continuously monitor the patients in this group.
Thank you, Kevin. As you can see, RRP and end-tidal CO2 are valuable technologies in assessing respiration rate across your patient population, helping you predict patient deterioration sooner. Fortunately, these technologies are available on easy-to-use devices clinicians are already familiar with, the Well-Challenged Connect monitors. First, let's discuss the Connect Spot monitor that enables you to acquire accurate, connected, episodic readings as part of routine vitals capture. This monitor includes digital respiration rate seamlessly added into your existing workflow using standard Masimo sensors. Leveraging the same intuitive interface and workflow you are accustomed to, you can now eliminate subjective measurements from visual respiration rate assessment and go digital, enabling this parameter to be incorporated into your early warning score protocol. It's critical that you have the right equipment for your patient population across varying acuity levels. For higher risk or higher acuity patients in your general care area, you need to be able to continuously monitor their CO2 to proactively identify and quickly respond to signs of deterioration. The Connect Vital Signs monitor enables you to do that in addition to capturing the other vitals you need for a full picture of your patient's health. Regardless of your patient population and your facility's appropriate mix of devices for monitoring respiration rate, it is critical to have visibility to a patient's respiratory status. The Well-Challenged Connect Central Station provides real-time status of all patients at a glance, so you can quickly respond to early signs of deterioration. Also, with EMR integration, your intermittent vitals and continuous monitoring data are automatically documented in the patient chart and accessible from anywhere in your facility. Changes in respiration rate are critical to discriminate between stable patients and those at risk for deterioration, such as respiratory compromise, which is the most common cause of ICU admission from the general care ward. It is imperative that you have an easy, accurate way to capture this critical data without impeding your workflow, and we are here to help. With solutions available from Hillrom, you can now digitally capture respiration rate across your patient population for a range of acuity levels. You can access this data immediately anywhere in the facility via your EMR or leverage the central station to view patient respiratory status. And the best part, you can do this leveraging your existing devices, fitting the ability to capture accurate respiration data seamlessly within your current workflow. Kevin and I thank you for your time, and now I'll pass it back to Natalie.
Thank you, Tiffany. We will now answer the questions submitted during the presentation. As a reminder, if you would like to submit a question, please do so using the chat box, and we will do our best to get to all of them. Thank you. Thanks, everyone, for attending our presentation today. I'm going to go through and just read some of the questions that came in through the chat during the presentation. Again, as a reminder, you can use the chat box to submit any new questions that you may have, and I will get started. Okay, first question here. If I already have a Connect Spot monitor with Masimo, does this require a specific sensor or cable to enable this new respiration rate measurement function?
Hey, Natalie, this is Tiffany. I can take that one. So if you already have a Masimo device, then the Masimo cable that ships with the CSM is the cable and sensor you can use. There is no need for another one. Both LNCS and RDSET cables and sensors from Masimo can be used. Additionally, you will also need to upgrade your software and purchase an RRP license from Hillrom.
Okay, thank you. Let's see, next question here. How do I know which patients I should be using end-tidal CO2 capnography monitoring on?
Sure, great question. We actually hear this question quite a bit. It's Tiffany again. We see end-tidal CO2 monitoring being used to safely manage patients receiving opioid pain medications, tying to that potential of unexpected respiratory compromise resulting from the effects of those pain management therapies, which the Joint Commission had outlined in their Sentinel Alert on the safe use of opioids several years ago. More recently, we have also seen end-tidal CO2 monitoring implemented for COVID-19 patients, where the accuracy and immediacy of respiration status is critical. Medtronic has also recently released a study called Prodigy that, sorry, I just lost my, oh, I apologize. So Medtronic recently released a study called Prodigy that does risk stratification across patient populations, and that can be found on our microsite.
All right, thank you, Tiffany. Next question here. Are there other ways to capture respiration rate beyond what we've seen here today?
Sure, another great question, thanks for asking. Yes, Hillrom offers a range of solutions that can help you monitor respiration rate and detect patient deterioration sooner. Within our patient monitoring portfolio, the Connect Vital Signs Monitor offers impedance respiration and Masimo RRA. Another option is through our Centrella bed using early sense technology.
Okay. We have, the next question is, so for spot check, we mentioned that in the presentation using Masimo RRP, how long does it take to get an RR reading from that?
Hey, Natalie, it's Kevin. I can grab that one. That's a great question. So, you know, not too different from many other parameter technologies you might be familiar with. You know, some of that does depend on the condition of your patient, but you'll typically see a reading in about 45 seconds when you're using the RRP technology. You know, think of that as fitting within the all-encompassing set of vitals that really would likely take about a minute for that clinician to collect. So it really does fit directly into that spot check workflow. You know, something to consider, you know, like when you're acquiring vital signs on most patients, you know, patient compliance, so a patient who's not talking, those types of activities are really important for a fast and accurate reading, but about a 45-second window is what you should expect.
Great, thanks, Kevin. We had another question come in. I think this is similar to one of the other previous questions, but what sensors can I use to detect respiration rate?
Sure, I can take that one. So you can use Masimo RRP sensors, either the LNCS or the RDSET cables and sensors, and you can use either the disposable or the reusable.
Great. Let's see, we just had another question come in. Can this be used remotely? I'm not sure if we need some additional context or if you want to answer that one.
I can take that, Natalie. I can start on that one. So probably a couple different meanings to the term remote, right? So I think as we're thinking about respiratory monitoring of patients, you know, when I kind of see remote, I would put that in the context of, as an example, inside of the hospital, these technologies can be connected into a central station that we also offer to allow sort of that remote monitoring capability of monitoring a patient in the room, you know, from a centralized view of those patients being monitored. So really all the technologies we talked about today do have the ability to have a centralization through a central monitoring solution that we could offer. So it kind of, you know, alleviates the need for the clinician to be in the room checking on that patient and gives them a remote view of that particular patient. Not really something at this point that's extended outside the four walls of the hospital, if that's kind of the context of the thought around remote. There was sort of a follow-up question to that I saw come through in terms of, can this technology be used in the home with a patient? And so that's not something we're able to do today. Obviously, we're always looking at opportunities where we can kind of extend our monitoring capabilities. We do have solutions that can, in fact, go into the home. But in terms of these respiratory monitoring technologies, these are really meant for a clinical environment, you know, inside a clinic, inside the four walls of a hospital for use by a clinician. Great questions.
Just had another question come through. How is patient data integrated into my EMR? Do I need to be using a specific EMR for this data to be integrated?
Yeah, terrific question, Kevin. Again, I can answer that one for sure. So, you know, we've got a couple different options for how this data can get integrated into your EMR. Really, Hillrom works with all the leading EMR providers, you know, Cerner, Epic, Meditech, Allscripts, as well as others. And we have different methodologies we can use to integrate your vital signs devices into your EMR, really dependent mainly on workflow, right? So we've got ways to integrate that spot check set of vitals into your EMR so that when the clinician enters the room, takes a set of vitals on that patient, they can basically transfer that set of vital signs for that particular patient directly into the EMR from the bedside. And then when you go beyond that and start to look at technologies like, you know, we talked about CO2 monitoring as an example, which is really more of a continuous monitoring activity. We have ways, I kind of mentioned the central station earlier, where that device can be placed at the bedside, monitoring that patient continuously on end-tidal CO2, and then that data can go through to a central station, so clinicians have real-time visibility to the monitoring activity that's occurring. And then from there, we can also further integrate so that data gets populated into the patient's record within the EMR as well. So a lot of it comes down to the workflow in terms of the level of monitoring you're doing and sort of the interaction you want that clinician to have and how you want that data entered into your EMR. But we've got, you know, really capabilities to automate that process, whether it's spot check or continuous monitoring, and really across all the major EMRs. So we can certainly follow up with you in more detail on that and connect you with a local representative. That would be helpful post-webinar.
Great. Thank you, Kevin. So we had another question come through. Am I able to measure respiration rate in my office? I know we mentioned a lot about a hospital setting, but I think this refers to more of a primary care setting.
Yeah, I can take that one, Natalie. Respirate using Masimo RRP technology is a episodic capture. So yes, if you were looking to do episodic capture of respiration rate in a physician's office, you would be able to use this technology.
Great. Let's see, I think we have time for maybe one, maybe two more questions. What is the difference between RRP and RRA?
Sure, I can take this one as well. So there are a couple of differences between the two technologies. They are both from Masimo. Masimo RRP is an episodic respiration rate that is captured differed from the SpO2 plus. Masimo RRA is a continuous parameter, and that is used by placing a patch that's about the size of the Band-Aid on your patient's neck, and it's basically a microphone that's listening for breathing. So it's gathering the respiration rate from listening for each passing breath. And again, RRP is from the plus on the waveform and is episodic.
Okay, thank you. One moment here. I'm just looking through to see if we have any other questions that came through. Let's see, it looks like we have time for one more question here. How sensitive is this? I'm presuming that this is referring to the sensor, and we might need to follow up on this, but how sensitive is it, especially with patients that might be cold, have arrhythmias, low hemoglobin, etc.?
So if we're talking specifically to RRP technology, it's obtained from the SpO2. So just like when you're gathering your SpO2 reading, you know, you ideally want someone who has good, warmer hands, higher hemoglobin, less motion, but it's really based upon the technology of the SpO2 supplier. You know, Masimo is, a good supplier for SpO2, good technology, and it would be based off of their accuracy.
Okay, thank you very much. And we'll do one final question here, and then some other questions may have come through. We will be sure to follow up with you guys after. If we were not able to get to your question, we will certainly follow up with you after this webinar. We'll just take this last one here. When you capture patient data, do you have any analytics or tools available to help with clinical decision support?
Yeah, this is Kevin. I can take that one for sure. That's a great question. I would say a few different things could really play into that. And again, I'll kind of relate it back to the level of monitoring that you're performing. If I think about spot check vitals for a moment, think about that single set of vital signs. Obviously, we started out talking about the importance of respiration rate measurement and the value that can have as far as identifying signs of deterioration. So one way that we see that being used often is through early warning scoring, and that can be done in a few different ways. So as an example, a Muse score or a Pew score, respiration rate is an important value as a part of that overall patient score. And so we can not only automate the collection of that measurement, but at the vital signs monitor level, we can also automatically calculate an early warning score on a patient using not only respiration rate, but the other values that you've measured during that session of collecting vital signs on that patient. So when we do that, we present a clinical message at the bedside that takes all those vital signs into consideration and calculates a score for that particular patient. Now, that's all done in a customized capacity. So if your institution has a standard for patient scoring that you use, basically think of it that our devices can essentially be customized to use that same protocol and generate a score based on that information that aligns with what your specific protocols are. So at the end of the day, we present that message at the bedside, we present a score for that patient, the clinician can then respond given the protocol that you have in place. If I step away from spot check and think about continuous monitoring for a minute, I'm going to talk about end-tidal CO2 specifically. Monitoring end-tidal CO2 obviously brings a new parameter into the picture. And so one of the things that really wanted to focus on as far as integrating that into our devices is making that simple for the clinician. And in close partnership with our business partner Medtronic, we really integrate some additional technologies. One of them being integrated pulmonary index or IPI. And what that does is really take multiple measurements that are collected during the act of monitoring a patient and essentially boil it all down to a single 1 to 10 scale. It's very, very simple for the clinician to understand and also helps them more easily identify somebody who might be going into respiratory compromise by really being able to simply look at one number that gives them a sense of that patient's ventilatory status. So we've got a couple different ways that we can really make respiratory monitoring, easy and really help the clinician more simply identify signs of deterioration at the vital signs monitor level.
Great, thank you so much. This concludes our presentation today. I'd like to thank Kevin and Tiffany for their time and for the great answers to all of these great questions. Again, if we weren't able to get to your question, we will certainly follow up with you after the fact. And everyone have a great day, and thanks for attending.
All right, thank you, everyone.